This is for 11.1b. It's curved mirrors, and we're going to solve this question. This is the first example from the slides, but I just wanted to quickly show you this in the textbook. This is page 421. Just this chart right at the bottom here. This is an important chart, and as you do the homework questions this week, I think it's a good idea if you can have this chart in front of you. It shows a couple of things. We can look at just this first diagram right here. It shows there's an object out here, there's a concave mirror over here. Concave just means that the mirror kind of goes in this way, like as if you're kind of walking inside of a cave, you know? It's kind of that shape. The object is out here, and you can see there's a focal length right there. So it kind of mentions it over here. If the object is more than 2 focal lengths, if the object is a long ways away, then the image is going to be nearer to the mirror than the object is, and it's going to be upside down. If we bring the object in, so you can see if we bring the object into here, quite close to the focal length, it describes it over here. If it's nearer, if the object is nearer, then the image is actually further away, and it's bigger. Okay, so in both cases they're upside down. They're inverted, is what we say. That's the word here, inverted. In both cases the images are inverted, but here the image is closer than the object to the mirror. Here the image is further away than the object from the mirror. If we continue to bring the object in when it's right at the focal length, no image is formed. The reason is these rays come off parallel. Anyways, no image is formed there. But if I continue to move the object even closer than the focal length, then I still get an image, but the image is now on the other side of the mirror. It's bigger and it's upright. So an important thing is to notice that it's upright. So right here it's upright. A couple things with this as well. If the object and the image are on the same side of the mirror, then that image is what we call real. So this guy's also real. Image and object are on the same side. Here there's no image. Here though, the object and the image are on opposite sides of the mirror. That's what we call a virtual object. Okay, so that's going to be important. Remember those two words. So they're real, they're on the same side. Virtual, the object is and the image are on the opposite sides. All right, let's try to go on and do this question. So it says we've got a 4 centimeter tall light bulb placed a distance of 18.3 centimeters from a concave mirror with a focal length. Okay, so here is a concave mirror. I'll put the little lines on the back of the mirror just to kind of say that's the back of the mirror. We don't know what's going on back there. But 18.3 centimeters away from it, there's this 4 centimeter tall object. The mirror has a focal length of 15 centimeters. So I'm going to say right here, let's say that is the focal length. So that's 15 centimeters. The object is a little further away. We usually draw an arrow. I don't know why. You can draw a light bulb, but usually people draw arrows. That's what you see in a lot of textbooks anyways. This object, so the height of this object is 4 centimeters tall. The distance of the object, I'm going to write it right here, is 18.3 centimeters. That's kind of this distance going this way. Okay, so the distance from the mirror to the object, 18.3 centimeters. Now, the image we're told, I'm just going to write over here for a sec, the image is produced 0.215 meters. First thing I notice is I don't like this mixing of units, right? Everything is in centimeters except that. We got to be careful of that. I'm going to assume by Gr10 Science, you know, there are 100 centimeters per meter. That means I'm going to divide by 100 to get 21.5 centimeters. Okay, that is our image distance. Okay, so don't use this number in meters. Use the number in the same units as the other things we've got. We're asked to determine the magnification of the mirror, right? One other quick thing is this. If this image is produced further away, like it is here, this thing must be a real image because of where the object is compared to the focal length. Let me say it that way. Again, this is on page 421, that chart that we just walked through. If the object is close to the focal length but outside of it, that means the image is actually going to be over here somewhere. It's going to be further away, as we see here, further away than this 18. It's also going to be upside down. Okay, so I know that it's going to be over here somewhere. I don't know the height of that thing, height of the image. That's one of the things I'm going to find. Okay, so there's our drawing. Couple things. Here's some of our given information. When you see this guess method, this G is given information. Here's the given information we've got. U is unknown. Okay, so for part A, For part A, it says find the magnification. Here's my unknown. Let me sneak this in quickly. For part B, it's image height. It's HI. There's my other unknown. I've got two unknowns that I'm looking for. So I know my given information. I know my unknowns. Let's talk equations. We know for the equations, we've got HI over HO, or we've got magnification is DI over DO. And I just want to make sure that we saw this in the note, there's a negative sign. In the textbook, there's no negative sign here. So there are multiple ways you can do this. I'm going to do it the way with a negative sign. That's kind of the standard way. I don't know why your textbook skips that. Okay, so don't miss this negative sign right here. That's part of the equation. When I look at this, if I'm looking for magnification, I need to know both heights. I don't know both heights. If I look at this equation to find magnification, I need to know both distances. I have both distances. Okay, so this is the equation I'm going to use. Okay, so for part A, let's sneak it right here. For part A, magnification is whatever DI is. Okay, so 21.5, and remember this negative is part of the equation. Okay, so that negative times that number divided by distance of the object, 18.3. Magnification, let's see, that is 1.1748. Okay, there's lots of numbers. I'm gonna write, your calculator will spit out a lot of numbers. We are gonna round this thing. On the slide, it mentions, for this example, it mentions watch your sig digs. Sig digs means significant digits. Typically we would go through and teach all this. We aren't going to do that this year. You'll find this out in grade 11, but the quick rule of thumb for sig digs is this. If your numbers have 3 digits in them, you're only going to keep 3 digits, which means you have to do any rounding that's appropriate. That's a 4. That thing stays as a 7. We're just going to say 1.17. There's no units. Sometimes people put an X, so to say it's 1.17 times as big, and that's fine, but either no units or an X, but 3 significant digits. For part B, they're asking for the image height. Okay, so now I'm back to this equation over here, but now I know the magnification. Really, you need 2 out of the 3 things in this equation. Okay, so let's start with this. Here's my equation. Remember, in this guess method, we write down givens, unknowns. We're also going to write the equation. So do show me which equation you're subbing into. Don't just start with numbers. Show me the equation, then start subbing these numbers in. And when I do a final answer, I'm going to do sig digs. But if I use that number, I'm going to use the unrounded value. If you still have this number in your calculator, keep it. Oops, I should have a negative sign in here. That negative right there is right here. And right here, I'll come back and talk about that negative. That negative, though, is important. Let's keep that in there. The height of the object, okay, we don't know the height of the image, right? That's what we're looking for. The height of the object right here is 4. I'm just going to rearrange. I'm going to bring the 4 up over here, or you can say I'm going to multiply this side by 4. I'm going to multiply this side by 4. Let's put this. Let's say forget the X. Let's just say I'm going to multiply by 4. I'll just use brackets. Over here, the 4s are going to cancel. I'm left with just H. Over here, I'm going to get a negative answer, and I'm going to get 4.69945. Again, I can't keep all of these digits. This is centimeters, but I can't keep all those digits. Again, 3 sig digs. I've got to chop this off right here. That 9 makes this go up to 10, so that's a 0, that's a 7. So this is going to be height image. So height of the image, negative 4.70. We're in centimeters, right? We put all of our numbers into centimeters in here. Let's talk about these negatives. This negative right here, if you've got a negative magnification, that just means the image, or the image flips over. So the object was upright. This guy is inverted. This thing right here also means inverted. Okay, so that's what these negative signs mean when you see these negative signs in here. The image is inverted.